Okay, so today we are doing lesson 7.2. This is similar polygons. So in order to start this lesson, we need to know, what does similar mean? So the definition: two polygons are similar if and only if all corresponding angle pairs are congruent. So if all their angles are congruent and all corresponding sides are proportional. So the reason we just spent a couple days doing fractions and ratios and proportions was so that we can get into the similar polygons, because we're going to set up a bunch of proportions and ratios today in order to show if or not if polygons are similar. Proportional means that there's a common ratio between our corresponding pairs of sides. So that means I can write it as like A over B, or some of us like to write it this way: A colon B, A to B. Those are all ways of having a scale factor. Now I'm going to give you like a quick example before we get into it too crazy. So like, let's say I've got a triangle right here. Here's a little baby triangle. I'm physically just going to do some notability magic and I'm just going to blow it up. So I took the exact same triangle. They're literally the same. I'm just making him a little bit bigger. Actually, a lot bigger. Perfect. It's the exact same shape. I did not change any of the angles. I didn't mess any angles. So these angles are congruent and the top angles are still congruent. And then the last corner, those are congruent as well. 3. Okay. Now the sides are what we call proportional, because I could have like a ratio that goes with them. So let's pretend that this is 1, that's 2, and that's 3. The side that's 1 is going to go with a side that's 5. So my ratio that goes between them is going to be a 1 to 5 ratio. So to get from 1 to 5, I multiplied by 5. Similarly, to go from 2 to this other angle, I'm going to multiply by 5 again, and that gives me 10. And then the last one is I'm going to take a side that's labeled 3 and multiply it by 5, and that means that my final side is going to be 15. So this is my ratio. 1 to 5 is my ratio, and it's proportional. So if I did any of these sides that matched up together, 1 and 5, 2 and 10, 3 and 15, they would simplify down to be 1 and 5. That's my proportion. Okay. Now, if you look at this, the example I did is I did one triangle and I copy and pasted it and just blew it up. So they're both triangles. Informally, for polygons to be similar, they must be the same shape. So it has to be 2 triangles. I can't have like a triangle and a, I don't know, like pentagon. Those are not going to be similar. So I'm going to put a little X through that. They cannot be similar because they're not the same shape. All the angles have to be congruent. Well, if a triangle only has 3 angles and a pentagon has 5, like how do I match those up? I don't. Doesn't work. So they must be the same shape, but they can be different sizes, which is what I showed you over here. I showed you a little baby one. I showed you a big one. Okay. The next question says, are congruent polygons also similar? Why or why not? I would argue congruent polygons, I'd say yes. I'd say yes, they are similar. And let's think about that. To be similar, I have to have all of my angles are congruent, and I have to have my sides are proportional. Okay, if I have 2 congruent shapes, 2 congruent triangles, let's say, are all their angles congruent? I'd say yeah, right? That's the whole point. Congruent shapes mean all their angles are congruent and all their sides are congruent. Well, for similar, they must have sides that are proportional. Well, if they're congruent, then their proportion is going to be 1 to 1. It's going to be whatever one side length is over its exact same measure. So it's going to be a proportion of 1 to 1. That's a ratio, that's proportion. So I'm going to say that also works, which is why I say yes. So all my angles are congruent and the sides are proportional. That's why I said yes. One other thing, some notation before we get too crazy with this lesson, is that little tilde, that little squiggle, means similar to. So it's like I took my congruent sign and I just erased the equals underneath it. Just the tilde. Okay. And then one more definition, and we're going to get started on some problems. It says the ratio of the lengths of 2 corresponding sides of 2 similar polygons is called the blank. So the ratio we make when we compare the sides is called the scale factor. The scale factor. So if I ask for scale factor, I'm asking for a ratio of sides. And as we start by looking at this first example, I want you to know that the order in which I write the vertices matters. So like if I write A, B, C, D, like that is similar to W, X, Y, Z, that's important because that tells me that angle A goes with angle W. What goes with angle D? Anyone know? Anyone know what goes with angle D?
X.
Not X. Sorry, D as in dog.
Oh, Z.
Angle
Sorry.
Z.
Good. Yep. Sorry, I didn't think to enunciate. So D as in dog goes with Z. Same thing with sides. So if I had like AB, that goes with WX. What if I said CB? CB as in
YZ.
B as in boy.
YX.
YX. Sorry, I picked like the worst ones to enunciate. I'm so sorry. We all understand it was just like a miscommunication of how I said my words, right? Thumbs up, maybe. Okay, I'm gonna assume I just didn't pronounce it good enough. So we know that that just matches up with each other. If I say CB, I'm going backwards, C to B, Y to X. Very good. Okay, now this big box, this big like table all goes with this problem. So we are told that triangle RST is similar to XYZ. So these two shapes are similar, and I already have it marked a little bit. I see that angle R and angle X are congruent. I see angle S and angle Y are congruent, and I see angle Z and T are congruent. That's just based on the number of little congruent marks in them. That means that my sides are now going to be proportional. So we have to figure out like which sides go together in order to do our proportion. And we have to start that off right at the beginning because it says we want to find the scale factor of RST to XYZ. When I say the scale factor of one to the other, that means I'm starting with the first shape and then I'm going to the second shape. So that means I'm starting with triangle RST on top and I'm going to XYZ. Now I only have one value in XYZ. I only have 15. So I have to know which side goes with XY in order to make this proportion. What side goes with XY? Anybody know?
RS.
Very good, Colin. RS. And so now that I know RS and XY go together, I'm going to actually put their numbers with it. RS is 20, XY is 15. I know I thought of XY first, but it still goes on the bottom because of the question that was asked. It says I want to go from RST to XYV. So XYV, XYZ is at the bottom. So I've got 20 over 15 and we want to simplify that. Always simplify, always, always, always. That gives me a factor of 5 can come out of both of them. So I get 4 over 3. Ooh, that's not at all what I wanted. Okay, anybody questions on that scale factor? Okay, the next problem says now I want to go from XYZ to RST. So now I want XYZ over RST. Does anyone know what that scale factor would be?
Would it just be 3/4?
It would just be 3/4. Very good, Allie. We just go the opposite way. So now instead of starting with RST and going to XYZ, we're going backwards. We're starting here and going there. I still don't have any other side, so I have to still use 15 and 20, but now it's 15 on top and 20 on the bottom, which does simplify down to 3 over 4. The exact same numbers, just flipped the order. And then from now on, we can use either scale factor. We can either go from RST to XYZ or vice versa. We just have to be cognizant of which proportion, which ratio we're going to use. So now it says find the value of x using a proportion. So we need to find out angle x, or sorry, side x. My first question is which side goes with side x? What's the corresponding side here?
ST.
ST, very good. So I have YZ and ST go together. So we want to make a proportion. It doesn't matter if you put the 16 on top or the x on top. I don't care either way. I'm probably going to do 16 over x. If I want the 16 on top and then I'm going to the x, which scale factor am I going to use? 4 over 3 or 3 over 4? If I started with 16, which is this shape, and then I'm going to the other shape, which scale factor am I going to use?
The 4 over 3.
Very good, Ella. The 4 over 3. So if I want to go from triangle RST and then go to XYZ, I have to have 4 on top and then 3 on bottom because I want the shapes to match. 4 represents the 20 and 16 and 20 are in the same shape, which is why they're both on top. And then 3 represents the 15 and X and 3 are both from the same shape and those, so they are on bottom. I said a minute ago, you could write it either way. You could have written X over 16, but then we would just need the 3 to go on top. It doesn't matter because I'm eventually still going to multiply X and 4 together, and I'm going to multiply 3 and 16 together. So either way you do it, you're going to get the same equation. 4x equals 16 times 3. 16 times 3 is 48. And so 4 divided by 48 is going to equal 12. Any questions on that one? Now the next one says write a proportion that relates to corresponding sides. I'm going to set this one up for you because it kind of is a little open-ended. I wouldn't really know where to start if I was you. So I've got triangle RST over triangle XYZ. So I essentially want to write a statement that has all of the sides that are proportional to each other. So I'm going to do RS over something, and then ST over something, and then TR over something. And so you're going to use the sides of XYZ and tell me what goes with RS and what goes with ST and what goes with TR. So who can help me? What should I put under ST? What goes with that? Oh, I jumped to ST. That's what I said.
YZ.
But I just went out of order. That was crazy. Thank you, Megan. YZ. What about RS? What goes with the first one?
XY.
Good. And then what about the last one, TR?
ZX.
X. Very good. Thank you, guys. Okay, not too bad. It's just important to know what goes with what goes where, set up a proportion, and then we would solve. This one was just setting up letters, no solving needed. Okay, that was our first example. We've got a couple more before we're done for today. Anybody have any questions so far? Okay, the next problem says determine whether the figures are similar. If they are similar, find the scale factor of WXYZ to PQRS and write a similarity statement. So first thing we have to remember is what does it mean to be similar? It means to be similar that all my angles are congruent and I need all my sides to be proportional, which means that they'd have the same scale factor, they'd have the same ratio. So if I think first, all angles are congruent. This is either yes or no, it's either given to me or it's not. And this one is just given to me. I've got W and P go together, I've got Z and S, I've got Y and R, I've got X and Q. So I just have them like labeled already, 1 congruent mark, 2 a congruent mark. And it's actually super simple because it's like it took one shape and it just slid it over and made it a little bit smaller. So it looks like very nice and clean and matches up nicely. So I'm going to say, yes, we have that. We're all good. We have all angles are congruent. Now I have to decide whether the sides are proportional. And I can't just do one set of sides and be like, oh yeah, they make a fraction. It's all cool. I need all 4 of the sides to be the same fraction. So I'll give us the first proportion. The first one I think of is WZ over PS. So that's going to be 9 over 6. So let's think about that. 9 over 6. If I can simplify that, they both have a factor of 3. So I get 3 over 2. Okay, cool. Can someone give me another set of sides, another corresponding set of sides to see if it's going to be 3 over 2?
WX and PQ.
WX and PQ. Very good. Colin, I'm going to do 12 over 8. 12 and 8 both have a common factor of 4 this time. And so I do get 3 over 2. Okay, awesome. We're on a good track. We're going to keep going. Who can give me another set?
XY and QR.
XY and QR. I heard Ben. XY over QR. 18 over 12. Very good. 18 and 12 both have a common factor of 6. So I get 3 over 2. Okay, we're on a good track, but we still have to check the last one. What's the last one going to be? What's the last one?
ZY and SR.
Very good, Isaac. ZY and SR. So I've got 15 over 10. So 15 and 10 both have a common factor of 5, and that gives me 3 and 2. Okay, awesome. They are all the same proportion. They are all the same scale factor, all the same ratio, which means that they are proportional. So we're going to say yes. That means that they are similar. I'm going to say yes, they are similar. We've got similar shapes here. Now, it said if they are similar, find the scale factor and then write a similarity statement. Do I have to do more work to find a scale factor, or am I already done?
Isn't it 3 over 2?
It is 3 over 2. Very good, Allie. We're all done, right? We found it. We did it. We're done. We don't have to do anything crazy. I'm just going to go over here and nicely write scale factor 3 over 2. It does say from WXYZ to PQRS, and we did that the whole time. We went from the first shape into the second shape. So we set ourselves up for success. If it said it the other way, we would just have to do 2 over 3. You also could write it with the little colon if that makes you happy too. So either answer is acceptable, 3 over 2 or 3, 2, 2. And the last thing we're going to do is write a similarity statement. Now it would be super easy to just write WXYZ is similar to PQRS, but let's challenge ourselves a little bit, okay? So let's say I gave you that we had to write it from ZYXW. What's the similar shape to that? If I said ZYXW, what would you say?
SRQP.
Very good, Ella. ZYXW, Ella went SRQP. Exact same way around the shape. And I could write it in whatever order I wanted to, and you just had to match the angles up next to each other. Perfect. All right, that one's done. Any questions? All right, good work, guys. Let's do another one, and then we're going to flip the page. This one says these triangles are similar. Okay, so that means their angles are all congruent and their sides are proportional. We want to find X. I see very clearly that I've got 2 sides over here. I've got 6 and I've got 12. What I want to do is figure out what goes with them in the other shape. So which side is like the corresponding side to AB? I'm going to do 6 over what?
X minus 3.
Minus 3. I had an angle at A and D, which are congruent, and then E and B are congruent. So I have to pick the side that goes with that, which is X minus 3. That means that now I've got 12 and then X minus 1. If you weren't sure why I'm allowed to say that, A to C is like 1 angle to the 2 mark. D to F is that exact same thing, 1 angle to the 2 mark. So I've got 12 over X plus 1. Anybody questions on how I set up that ratio? Or set up those ratios to make a proportion? Sorry, I'm trying to be better with vocab. All right, cross multiply. 12 times X minus 3 equals 6 times X plus 1. Distribute, I get 12X plus, minus 36 equals 6X plus 6. minus 6x from both sides. And at the same time, I'm going to add 36, so I don't have to worry about that later. That gives me 6x equals 42. Easy division, x is going to equal 7. All right. It's pretty simple algebra once you set the equation up right. If you had mixed up your x minus 3s and your x plus 1s, you would have gotten something completely different. That was wrong. So the algebra part should be super simple and we should be like, oh yeah, heck yeah, we get to do algebra, but you got to make sure you set it up correctly. Any questions on that setup? Okay, I'm actually going to stop talking for a minute because I want you to try this problem. It's kind of a big giant box, but it's not too much work. So we're going to do example A through H. I'm going to be quiet for a couple minutes so you can try it on your own, and then we will do that last one, and then we're going to go eat some lunch. Cool. So go ahead and try that one. I'm going to join you in a couple minutes. Okay, take another minute. Do what you can. All right. Okay. Especially if you're not really sure what's going on, we're going to come back together. If you do know what's going on, awesome. Let's just check our work then. Okay. So it says if quadrilateral ABCD is similar to quadrilateral EFGH, find the following. So we have to find a scale factor of ABCD to EFGH. Ooh, it looks like I only have this side right here of 6 of HE. What goes with HE? Does anyone know which side goes with HE?
DA.
DA. Good. I like how carefully we all said that, DA and not AD. So that means I've got 8 over 6. And remember, I put the 8 on top. I put the DA on top, even though that was the second thing we found, because we're going from the triangle, the shape, the quadrilateral on the left to the one on the right. So 8 over 6, we can simplify down to be 4 over 3. Okay, cool. Easy. We're going to keep using that ratio this whole time. So to find EF, I'm going to keep everything the same. I'm going to do 4 over 3 equals something over X, because we're looking for all of the shapes in the right-hand shape. So if I'm finding EF, which side goes with EF?
20.
20, very good, my AB side. So I'm going to put 20 over X to find this one. Thank you, Tyler. All right, cross multiply, I get 4X equals 60, and then divide by 4, I believe I get 15. And I'm going to label my picture as I go just so I don't forget what I'm doing and what I'm finding. Okay, now I got to do the other one. The next one says FG. So which side goes with FG?
BC.
BC. Thank you, Isaac. BC. So I'm going to do 4 over 3 equals BC was 12 over X. Cross multiply 4X equals 36. And then, oh, that's perfect division. I get 9. Good. I'm going to go fill that in up top. And then the last one of these we have to do GH. 4 over 3 equals what over X or what over GH? Four over 3 equals what over X?
25.
Thank you, Ella. 25. Very good. The last side, right? I hope that we just thought that was too easy. It didn't warrant an answer. The hard thing about this is there's not a lot of work for me to show. So like if you don't understand why like we're picking 20 or 12 or 25, you got to make sure that you let me know because I can't really like algebra show you out from here. If you do get it, awesome. It's not meant to be that difficult. And I think I've told this to you guys before. This is one of the units that people do really, really well on. So especially if you're like not thrilled with some of the way some of our quizzes and tests have gone, let's make sure we try really hard because we will have a test coming up on this coming up soon. I cross multiplied and I got 4x equals 75 and I'm going to just divide that by 4. Ooh, that is not as pretty, but that's okay. You're allowed to get decimals for sides. You're allowed to get decimals for angles. It happens sometimes. And a way that I know it's okay is usually it's a pretty nice decimal. It's not going to be like 18.75819 something, 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 something. This one ended really nicely at 7.5. So all good there. Okay, so those were all of our side lengths. We had to do our proportions for that. Now I want to do something with the perimeter. So how do I find the perimeter of ABCD? What do I do there?
You add all the lengths together.
Add all the lengths together. Very good. I'm looking at ABCD, so I'm doing 8 plus 12 plus 20 plus 25. Yep. And that all adds up to, I believe, 65. Does that sound good to you guys? Any complaints? All right, now I have to do the perimeter of EFGH. It's the exact same idea. What did we get when we added all those up?
48.75.
48.75. Good, Isaac. 48.75. Again, I had a 0.75 up here, so it's going to make sense that I'm going to have a decimal on this answer. When you add them all up with the decimal, you're going to keep that decimal. Okay, that's not hard stuff. Hopefully that was like, oh yeah, duh, add up all the sides if you weren't sure what to do. Now I'm going to do the ratio of them. So ratio means we're doing one number over the other, and we're doing the perimeter of ABCD, which is 65, over the perimeter of EFGH, which is 48.75. Okay. Normally we get here and I'd be like, all right, guys, like what's the common factor? What can we divide out? All that fun stuff. However, we've got a decimal and I don't really know what to do there. If I don't really know what to do, I can throw this in my calculator and find a decimal and then see if I can relate that to something else. So I'm going to do in my calculator, I'm going to do 65 divided by 48.75. I'm just going to physically do that division and see what that is as a decimal. And it's approximately 1.333 or 1.3 repeating. Again, if those were nice, pretty numbers that I could just, take a 5 out or take a 2 out, I would do that, but they're not. I can't do that with a decimal. So instead I put it in the calculator to see if that can kind of help me find what it goes with. And if you look back at the beginning, the scale factor we used for all of those problems on the left was 4 over 3. Well, what's 4 over 3 if we put it in the calculator? What's that as a decimal? It's the exact same thing as what 65 over 48.75 is. What this shows you is every side individually goes with the scale factor, but then also the sum of all the sides or the perimeters of all the sides also follow the scale factor. So the conclusion, the point I've been trying to prove with this big problem is that if two polygons are similar, then the ratio of their perimeter equals the scale factor. So if I only wanted to know what the perimeter was from the very beginning, I didn't have to find all of these sides that we found. I could have simply found the perimeter of the first shape, A, B, C, D, by adding 8 plus 20 plus 12 plus 25 and doing 65 over X equals 4 over 3. We could have just set up a proportion and we wouldn't have had to do half of these other boxes. Okay. Let's actually show that in action. Let's do that on the next problem. The very last problem says if triangle DEF is congruent to triangle GHJ, find the scale factor of DEF to GHJ and the perimeter of each triangle. So what we're going to do is we're going to find the perimeter of DEF and then find the scale factor between them and then use that to solve. So let's do our scale factor first. Think about it for a second. Scale factor, it looks like I only have 12. Which side goes with 12?
8.
8, very good, Colin. I should have asked you which like sides go together. JH goes with FE, but I said that not as nicely. But yes, you're very right. 8 goes with that. So I'm going to do 8 over 12. That was my EF over HJ. I had to do those two. I couldn't do 10 or 12 because there's no sides over here. So I can't just like make something up for that. I have to actually use the two numbers I have. So 8 over 12, I can simplify down by 4 to be 2 over 3. It did say find the scale factor of DEF to GHJ, which is why I went from the left to the right. So in this case, the one on the left is smaller than the one on the right, which is why it's a smaller number on top and a bigger number on bottom. So that's my scale factor. So in order to solve for the perimeter of GHJ, I'm going to use a little P for perimeter. I have to actually find out what the perimeter of DEF is, which shouldn't be too hard. 10 plus 12 plus 8. That equals 30. And then we plug 30 in on top. Again, DEF are the two on top, the 2 and the 30, and then 3, and then we don't know the perimeter, the P go on the bottom because those are the second triangles. And now we cross multiply. So I get 2P equals 90, and then we divide by 2 and we get P equals 45. And remember that's perimeter of triangle GHJ. I'll zoom out for a second if anybody's looking at that. Ella, I'm looking at the question that you asked me, and that's a really good idea to do, to divide by 5, to break it down a little bit more. And that does work. The only problem is that you still have a decimal in there. And so that decimal, we'd have to like keep solving to get rid of that decimal in order to get like the nice 4 over 3. I think we could multiply by 4 on both the top and the bottom, and that would cancel out that decimal. And then we could, you know, simplify that down with math like we normally do algebraically. But since we haven't done that a lot, trying to get rid of the decimal here, I just put it in the calculator to see if that works. But I liked your idea. I think that was really, really, really smart. Does that help answer your question?
Yes, thank you.
Welcome. Sorry, I couldn't type that out. I'm having a hard time multitask, but that was a good question. So you definitely can try and do this algebraically if you want. Okay, any questions on this page? Any questions on the notes? Okay, one thing before I let you go, make sure that you go look at your homework. I do not see you until Tuesday, so it's just 10 problems. It should go pretty simply. there is quadratic formula on the back. So you'll need to use your notes, not from today, but from the day before to help you with quadratic formula if you don't remember that. The front side is all similar polygons, and so you should see similar problems or key terms or whatever that's on our notes that we just did today. Okay, other than that, I'm done sharing. I'm here to help you if anyone needs help for the rest of class.